In this problem, it asks us to construct a frequency distribution with 5 classes, and we start with a lower class limit of 126.9 volts, and the class width is 0.2 volts. So I'm going to zoom in on our little table here and the data set. So they told us that the class width is 0.2. So that means that we're going to add 0.2 each time we go to the next lower class limit. So this lower class limit is 127.1, and then this is 127.3, 127.5, and 127.7. Then we figure out our upper class limits. So we have 126.9 to what? We want to know what goes in this blank. The next lower class limit is 127.1. I want to go back one step from 127.1 and get to 127.0. And then again, I can add that class width to get my next upper class limits. So 127.2, 127.4, and I just keep adding 0.2. So this way we don't have any overlap between the classes. So we have 126.9 and 127.0 in the first class, and then 127.1 and 127.2 in the second class, and so on. Okay, so now we're going to find our frequencies. So I'm looking for the values, first of all, 126.9 and 127.1, or not 0, because those are the values in the first class. Usually there's more values in a class than just 2, but in this case there's only the 2. So I'm going to look for 126.9 first of all. So we have that. 2. So 2 of those. 127.0. 1, 2, 3 of those. So altogether we have 5 values. And that's my frequency for that. And now I'll look for 127.1. 1, 2, 3. And 127.2. 1, 2. So again, 5. And then 127.3 and 127.4. 1, 2. That was for the 0.4. Let's take a look at 0.3. 1, 2. All right, so there's 4 for that group, and then 127.5, 127.6, 5 is 1, 2, 3, 4, 4 for that, 1, 2, 6s, so there's 6 for that group. And then finally 127.7 and 127.8. 0.8. And we've got how many left? 1, 2, 3, 4, 5. Okay. So I don't really need to count them, each value individually. It was just easier to do it that way. So for me. So that's how you get your frequency distribution. And now we want to know, does this appear to have a normal distribution? Why or why not? So I would say this is not a normal distribution. A normal distribution is going to start low and increase towards the center and then decrease as you go down again, or as you go on further. So this would be more of a normal distribution. In this case, we have 5, and then 5, and then 4, and 6, and then 5. So this is closer to a uniform distribution. It's not perfectly uniform. I'm going to call it uniform-ish because it's closer to uniform. So that is how you do that problem.